Launch and deployment. The James Webb Space Telescope, JWST, was launched on December 25, 2021, aboard an Ariane 5 rocket from Europe's spaceport in French Guiana, a gift to humanity on Christmas Day. This powerful rocket was provided by the European Space Agency, ESA, as part of international collaboration. But launching was just the beginning. What followed was a complex, high-stakes journey, a month-long ballet in space, as Webb made its way to its final destination, a special spot in space known as Lagrange Point 2, L2, about 1.5 million kilometers, or nearly 1 million miles, from Earth. During this journey, Webb had to unfold itself piece by piece, like a massive origami structure built for space. Here's what had to happen, perfectly and in sequence: deploy the solar panel to generate electricity from sunlight, extend the communications antenna to send data back to Earth, unpack its 5-layer sunshield, which is about the size of a tennis court, to protect sensitive instruments from the sun's heat, unfold the secondary and primary mirrors, precisely aligning 18 hexagonal segments to function as a single, giant mirror, cool down its instruments to ultra-low temperatures, necessary for detecting faint infrared signals from the distant universe, fine-tune the alignment of all mirror segments, a task so delicate it required nanometer precision. All of this had to be done remotely, with no chance of human repair. Unlike the Hubble telescope, which orbits Earth and can be serviced by astronauts, Webb is simply too far away. Every step had to be flawless, or the mission could fail. A window into the past. By July 2022, Webb was fully operational, and the universe would never look the same again. Its first images stunned the world. We saw brilliant galaxies colliding, star nurseries glowing with life, and the deepest views into the cosmos ever captured. Light from these objects had traveled billions of years to reach us. With Webb, we are not just looking out into space, we are looking back in time. Thanks to its cutting-edge infrared technology, Webb allows us to watch stars and planets forming in real time within swirling clouds of gas and dust, observe galaxies as they were billions of years ago, helping us understand how the universe evolved, study exoplanets, planets orbiting other stars, and analyze their atmospheres for signs of life or habitability, even explore objects in our own solar system, like Mars, Jupiter, and distant icy moons with its unmatched sensitivity. Webb can detect heat signatures, pierce through cosmic dust, and reveal secrets that were invisible to previous telescopes. Looking ahead, James Webb Space Telescope is not just a scientific instrument, it's a testament to human cooperation, perseverance, and imagination. It took over 30 years to design, test, and build. It cost nearly $10 billion, funded by NASA, ESA, and the Canadian Space Agency. It involved thousands of engineers, scientists, and technicians across the globe. Webb is expected to operate for at least 10 years, and possibly up to 20 years, depending on how long its fuel and systems last. Every day it operates, it sends back data that helps answer some of the biggest questions we've ever asked. How did the first galaxies form? What is the origin of stars and planetary systems? Are we alone in the universe? What mysteries will it solve next? As Webb peers deeper into the cosmos, we are likely to encounter new questions, surprising discoveries, and perhaps even evidence of life beyond Earth. The universe is vast and ancient, and with tools like the James Webb Space Telescope, we are finally beginning to explore it in detail. If you found this journey through space and time fascinating, make sure to check out more videos about space exploration, science breakthroughs, and the wonders of the universe. And if you want to, the James Webb Space Telescope, a journey into deep space. The most powerful space telescope ever made is the James Webb Space Telescope, also known as JWST or simply Webb. In this video, we'll explore how Webb works, how it was built around the world, and how it was launched into space. Hi, I'm your guide today, here to help you understand the incredible story of Webb, a telescope that lets us look deeper into space than ever before. Why we use telescopes when we look at the night sky, we see stars, the moon, and maybe a few planets. But our eyes alone can't see very far. To look deeper into space, we use telescopes. A reflecting telescope, for example, uses mirrors to gather light. The larger the mirror, the more light it collects, just like a bigger bucket collects more rain. That light gets focused and sent to an eyepiece or a camera, allowing us to see faraway stars and galaxies. Why look from space? On Earth, our atmosphere distorts light, making space images blurry. Some wavelengths of light can't even reach the ground. So, astronomers build space telescopes above the atmosphere for clearer views. The Hubble Space Telescope, launched in 1990, was the first major space observatory. It gave us amazing images for over 30 years, including the famous Hubble Deep Field, where scientists looked at a tiny, dark spot in space, and found thousands of galaxies. But Hubble mostly sees visible light, like our eyes. The universe, however, shines in many types of light, including infrared, which our eyes cannot see. Why infrared is important? Infrared light is basically heat energy. We can't see it with our eyes, but infrared cameras can. As the universe expands, the light from distant galaxies gets stretched into infrared wavelengths, a phenomenon called redshift. That's where the James Webb Space Telescope comes in. It sees infrared light, letting us view the earliest galaxies, hidden stars, and even planets around other stars. How Webb is different? Unlike Hubble, which orbits Earth, Webb orbits around a point 1.5 million kilometers away from Earth, called Lagrange point 2, L2. This spot is stable and keeps Webb far from the sun's heat and light. Webb must stay extremely cold to detect faint heat signals from distant stars. To protect it, engineers built a 5-layer sunshield the size of a tennis court. It keeps the instruments cold on one side while the electronics stay warm on the other. Webb's giant mirror. Webb has a large gold-coated mirror made of 18 hexagonal segments. These mirrors fold for launch and unfold in space. The mirror is made of beryllium, which is strong, lightweight, and holds its shape in the freezing conditions of space. Gold was chosen for its ability to reflect infrared light. Together, these segments act as one massive mirror to collect faint light from the universe. The global effort behind Webb. Webb was built by NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Parts were built and tested in several places. The mirror segments were made in the US, assembled in Colorado, and coated with gold. The sunshield was made in Alabama. The scientific instruments were assembled at NASA's Goddard Space Flight Center in Maryland. Final testing took place at Northrop Grumman in California. The fully assembled telescope was then shipped, by boat through the Panama Canal,